All right, welcome everybody to our product peek with us at Braincube here. It's really great to have all of you. My name's Danielle Rand. I'm a global growth marketing manager here with Braincube. I'm here to MC to introduce our presenter, Manuel DePoe today, who is our senior sales engineer in EMEA. Today's product peak session and demo is really going to focus on how to optimize your manufacturing processes. And specifically, we're going to be taking a look at our cross-rank application and AI, and how you can plug that into your existing industrial tech stack for better process optimization. So with that, I'm going to hand it over to Manuel. And one more thing, actually, we love doing these mostly for like the questions that you all have, and we really want to be here to answer them. So please use the chat function to put your questions in as we're kind of going along the presentation, and then we'll get to them at the end. And with that, yeah, Manuel, take it away.
Thank you, Danielle. Welcome, everybody. My name is Manuel, like Danielle presented. I am pre-sales engineer at Braincube, and I will present you today the optimize capability, one of the optimizing capability of Braincube, focusing on our advanced analytics. So I will make this in two parts. First, I will show you a few slides to give a background of us and also about the platform. Then we will switch to a quick demo. It's an accelerated demo, sort of. I hope this will give you the will to contact us to know more about the platform. And then we will switch back very shortly to a few slides to explain how a typical customer gained using Braincube. So I will switch and share my screen now. Maybe Danielle, you can just confirm that my screen is displayed.
You can see your screen and just hitting the slideshow button to enlarge. Yeah, there you go. Perfect.
Okay,
Awesome.
fantastic. So first, a few words about who we are, what we do. So we are a software company at Braincube. The product is also called Braincube, so it's both the name of the company and the software. And what we develop as a software company is a platform to help every manufacturer basically optimize production lines by taking advantage of two things: data, this is the fuel of our software, and AI. This is the engine of our software, basically. And so I want just to move forward, and looks like I'm blocked. Danielle, can you see my screen?
You can still see it. You're still on the intro slide.
Okay, I just cannot switch from this slide to something else. So something is happening. I will share again. Sorry, first time this happens. Okay, okay, something was blocked. Sorry.
Okay.
We are at an exciting time at Braincube. Basically, we were founded about 16 years ago. We made Series B funding in the late 2023. We almost raised $100 million to accelerate our growth, and also more important, to develop an even better solution. We are recognized by the analysts like Gartner, for those who are aware of who is Gartner, at the company who is able to deliver in this market. So we have an approach which is very focused on our customers. And we estimate that we have helped our customer base save about $10 billion in the last 10 years. We have about 300 customers. So it's an exciting time, like I said. And okay. I've got a weird behavior today of my WebEx, so I'm sorry. Just a few words about the platform, the product. What we deliver is a software, like I said, and the only layer on this screen that we don't provide is your data sources, your operational technology data sources and your information technology data sources, basically. So we start from connecting to the data sources. We collect this data, we push that to a data lake where we transform this data into a digital twin, which is a data model representation of the processes. And so we are able to run our algorithm to find hidden correlations between all the variables that make up a digital twin, that make up a process. And so that's what we will focus on today. You understand that it is a very exhaustive platform. We cannot demo that platform, of course, in 10 minutes. And so today we focus on the ultimate layer, which is the layer 6 in this layer split of the features. And I will switch just now to the demo. Okay. All right. So can you see again my screen?
Yeah, we can see Braincube.
Okay. So what we are seeing now is the Braincube platform, the Braincube interface, where we have a dashboard. We have dashboards, and we will take the example of an energy consumption that needs to be optimized. This is a topic that we are often asked to intervene. The energy prices are rising a lot, and so the energy optimization is a really important topic. So in this example, we have a boiler that takes for its combustion, that takes a few parameters, a few ingredients to work. It takes natural gas. It takes biomass. It's a biomass boiler. We are also able to boost the combustion thanks to oxygen, and we are also able to adjust that combustion thanks to an air valve. So we have a few things that we want to understand. We want to understand the correlation between all those parameters that are independent, and to optimize our combustion. So I will start from a dashboard that we have created using Braincube, sorry. And I will not focus on those dashboard capabilities and so on, but as you will see here, we are able to build dashboards that represent a topic. And in this case, I will directly go to the chart module, which is the data visualization module of Braincube, to trigger an analysis. So I will, again, not focus on those features. I will just filter here to take the full range of data. I could have done that using those filters and so on. And the beauty of the tool is that from that chart, which represents the natural gas consumption of my boiler, I will be able to trigger directly an analysis by just clicking on that button. And so, again, for the sake of this demo, I will keep it simple. I will stay on a mono objective, meaning that I just want to decrease the number of normal meters cubed per hour that I consume with that boiler. And so I will let the wizard drive that analysis process. I will confirm that I want to analyze that natural gas flow consumption. I will keep that date interval. I will also confirm the filters that were active on this chart. In fact, I only took into account the periods where the boiler was on. I don't want to have my average being perturbated by a period where, like this period where we don't have the boiler on. And I will click on next. I could avoid period of time where I know that my sensors, for instance, were not really reliable due to a maintenance period or an external weather event, for instance. So I could do that. In my example, I don't do that. And I will set an objective of what I want to do. Here, I want to reduce something. So I will put a maximum my objective will be to reduce, so I will put a max and not a min. It depends on the situation, what you want to do. In this case, to keep it simple again, I will put myself at the median. You see that this wizard is proposing me a reminder of the median for that phenomenon. And by doing so, I am splitting my data points in two categories, the bad and the good points. The bad points are represented in red and the good in green. So we are split by about 50% for each. This is important to understand because at the end of the day, the tool will simulate me improvement that I will be able to make by putting new settings for the different variables. So at the end of the day, if I have 100% of improvement, it will mean that all my red points will be converted into green points. So that's important to understand what is baseline and what it corresponds to. And again, I let the tool drive me. So two approaches, we could let the tool compare the output variables, natural gas flow output, with all the variables that make up my digital twin. Or I could filter because I just want to make an analysis on the controllable variables. I can do that very easily. By doing so, I can choose a group like that. It will refine a bit my list of variables. In this case, I keep 760 variables. I want to keep a fair amount of variables so you can see that it's pretty quick. I click on next. I will let the tool give a name for that analysis. I will leave the default for the rest. I just click on save. So basically, I just had one area where it was very important to understand what I was setting as an objective. For the rest, I was very assisted. So I'm making actually something very complex using a very guided way. And so, as you could see, about 20 seconds, 30 seconds, we already have the results of that comparison between this output variable and the different variables that make up my digital twin. I've got a reminder of this baseline we just set. And here we have the result of that analysis. So here I've got those 761 charts sorted by something we call the cross rank, which is a name that we have given to our proprietary algorithm that compares the impact of the variable on the output. So the output was natural gas flow output. It's correlated to itself. Good news. By 96% because the algorithm is looking at the outliers, potential outliers, and making some cleaning. And then we have different variables compared to this one in terms of impact. And so we can see that this variable, for instance, is correlated to 47% to this one. And so this is typically where we stop and have a discussion with the people from the process because they know well the processes and they know if those variables are dependent of those one, etc. But we can start seeing a few things. We can start thinking that, for instance, the date is correlated pretty well, 41%. So there is like a season effect. And we can start that some different variables here are pretty well impacting also. But we will focus today on the combustion of this boiler. So I will open this variable, which is the boost we get from the oxygen. And by just clicking on this chart, I will open a very specific chart that you'll see in a second. This chart is giving me two things. It's giving me actually the where I was in my historical data. I was set between 2% and 14% for that oxygen boost. And it tells me that when I was between 4 and 5%, which was my most common setting, I was there 4,000 times. Actually, I am inducing a negative impact on my combustion. So I'm consuming 15 more points, which, if you remind, were about above. We were under 1,300 the limit of combustion, were in fact in the red zone. So it means that compared to my historical data, this induced a negative impact of 15%. And if I am between 3 and 4, it's even worse. So it's pretty interesting because my main setting was inducing bad results. So the tool is telling me what setting I should use. So I would be better between 4.7 and 14. And so I will let the tool, I will create a rule based on this observation. I will do the same for another setting. I could do much more. I can do more complex rule, but for the sake of this demo, I will keep it simple again. So I'm creating a rule based on this new setting that the tool is identifying. I am moving the screen. Okay, let's have a look about the air. Here it is. And again, another interesting observation, we see here that we have 3 main settings, one here, and one here. And the last one, which is the most frequent one, is inducing bad behavior also. We have 58% of green points, which are in fact above that average. So the tool is telling me that I should be set between 59 and 75. So I will create again a rule based on this. Okay. Go back to the list. And in fact, I will go directly to the rules I created here. And what I will do, I will create a combined rule because this is a multivariate phenomenon. Okay. I will open it here. I will explain what it gives me as a result. So basically, this rule, which has 2 variables, is telling me that I will be able to enhance my average from 1,324 to 1,094. So that's a pretty nice result. It also tells me that this rule is pretty robust because in all my historical data, if I had been in those settings, I would have been always under the blue line, which represents the historical data behavior. And it also tells me that those settings were present 32% of the time in my historical data. So this is not a difficult situation to reproduce. This rule is not so aggressive. So I will be able, I'm pretty confident in the fact that I will be able to reproduce this set of settings on those 2 variables. So very rapidly, I could create a simulation of what I could expect as an improvement, as a lift, if I use this feature. So basically here, I've got a lift of 63%. So I will raise from 50 green points to 82 green points, if you remind the objective that we set to be under the median of my behavior. So I will keep there for this very rapid demo. From there are many things we can do with the platform, like enforcing the respect of this rule on the shop floor, etc. And I will just conclude with an example if we have enough time. Daniel, tell me if we are just over, if you don't mind, or...
We're kind of at the top of the hour, but it might be nice to just kind of take it full circle with a wrap up on the example.
Okay.
We still got most folks with us, so thanks for bearing with us.
So again, switching back to the slides. And so, yeah. Actually, the example I was showing is a clear copy of a very concrete case, a very actual case that we had to solve many years ago. In the paper industry, there are biomass boilers that produce steam, and for some reason, an industrial came to us with because they did not have a good efficiency for boiler. It was running at 42%, and so it was pretty low even for a biomass boiler. So they wanted to increase that efficiency, and this occurred at a time where also the CO2 emissions were very under the radar, on the radar of ecology, and so new regulations were put in place. So there was a lot of pressure on the industrial to accelerate the transition, and so we were asked to optimize that boiler. And so we basically what we did, like in many projects, we start collecting the data, look at the historical data. We made up calculated variables because sometimes you have sensors, but you need to have more high-level KPIs which are more meaningful for your business. So we start by creating those calculated variable and look at the historical data to understand phenomenon. It was a first important step for that customer. And then, like we said, like we made in the demo, clearly we find the key optimization to change the way that boiler was run. And we were so happy about the new settings that we had found that we built for that customer, and that's another feature of Braincube. We automatically built directly from those new settings live prescriptions, and so the operators could react in much less time than they used to do, and also with good prescriptions. And the results at the end of less than a year was in fact to increase from 42 to 58% the efficiency of that boiler. 1.2 million euro of saving could be done just with one boiler optimization. And at the same time, the reduction of CO2 emission were in the magnitude of 30%. So the gain was so important that it induced a more data-driven approach in the whole company, and which was not at all driven by data before. So very short again, but I hope it is clear enough, and you have plenty of questions.
I actually like sitting through these because every time I do, I feel like I learn something new or I can like sum up what we do easier. And I think Braincube's like a really big product overall, but I think the way you broke it out, it's really about the optimal settings might not be the ones you've been running your processes on for like months and months and months at a time. And Braincube can help you maybe find like hidden correlations that you weren't expecting to better optimize your process and the boiler example, but then also how that impacts like your bottom line and like real dollars from a results perspective. So thank you, Manuel. For questions, I see a few. We'll kind of use like this last minute here for everyone to use the chat if there's some additional ones. So throw them in there. But some of the ones I saw come in, how connected or integrated does my IT infrastructure need to be to support analytics like Braincube?
Yeah, good question. So, like we said in the introduction, we use data as a fuel because we need the data, and the more data basically we have, the more powerful is Braincube, because the more things we do that a human brain cannot do. This is where we get that recognition. So we need to have data, and for there is no typical infrastructure because we clearly adapt to ecosystems in place. Even with large customers, they are deployed in different geographies with factories that they had acquired. And so we clearly have to adapt. That is from the that is part of the concept of Braincube to be able to connect to different sources of data. But we do need to have some sort of data.
just saw one come in. Could you tell us how you face scalability and could work on site slash within a European organization?
How can we work with an European organization?
Yeah, and how do we
Is that the question?
face, yeah, how do we face like scale into other sites and into European organizations?
How the platform is designed to be able to address. This is something we didn't see because that was very fast on that part. But basically, you can connect from one single point to different sites, and also within a site, you can also segregate your data if you don't want to mix everything within the same digital twin. But all our customers are spread over large geographies. Um, so yeah, we maybe the question is also about where do we gather the data somewhere? Yes, we capture the data from the different sites and we put that in the data lake, a common data lake, and there we can run our algorithm. So our software is hosted in the cloud with all the security, of course, that it implies.
I would also just add one more thing to that question too, because I think it could go in a lot of directions,
Yeah.
is we have different users of Braincube as well. So from like a scale perspective, a lot of I'd say what we covered today was more for the process engineer within different sites, business units that could all be connected, which is what you were saying, Manuel. But we also have a different kind of functionality within Braincube that's more, I'd say, like corporate focused. It's our studio center and
Mhm.
dashboards, which kind of gives like more of a bird's eye view for an entire organization, how their plants are performing overall. That's kind of less of the day-to-day process optimizations and stabilizations and more like a report card for executive kind of level management for how different BUs or plants are performing as a whole. So just
Yeah.
another way to kind of scale from like the shop floor to the process engineer all the way up to
Yeah, the
leadership level.
platform serves different usages indeed. Yeah, like from operators to process engineers to factory managers, production line managers, and so on. Indeed, yeah.
Great question, though, and happy to follow up with you on that as well after this presentation today. The last one I see here is, are there other pieces of tech that Braincube can plug into? And if so, what? Like MES, Historian, etc.
Yeah, we clearly connect to what is present, and so we are able to connect directly to machines, PLCs, and so on. But when there are historians in place or MES in place with large amount of data in it, because the data has been already collected and stored and gathered in those places, and we connect to those places very frequently indeed. Yeah, we are able to do so, and we do so at almost every project also.
Great. Um, any other questions? Now's the time. I don't see any additional ones here. So I think with that, we can wrap things up. Thank you so much, everybody, for hanging with us today for a little longer than usual. We do these once a month, so the next one will be the first Thursday in August, same time. I believe it's August 5th. We typically cover different kind of product within Braincube because, as we kind of covered, there's different areas to dive into. It's a large product. So you can always catch us next time. And then we'll also be sending a recording as well. Thank you so much, Manuel. And thanks everybody for again joining us
Thank you.
today.
Thank you, Daniel. Have a lovely day.
Thanks, everybody. Bye
Bye
bye.
bye.